Have you ever wondered what would happen if an asteroid threatened Earth? No, I'm not talking about the plot of a blockbuster movie. Imagine the drama of a cosmic rock hurtling towards us, threatening our very existence. It's a risk as real as slipping on a banana peel, or maybe getting struck by lightning. Sounds far-fetched, right? But it's not as improbable as you might think. But don't worry, we're not just sitting ducks waiting for an asteroid to crash our party. So, how do we defend our lovely planet from these space rocks? Do we have a Superman or an Iron Man in real life? The short answer is no. There are no caped crusaders or armored geniuses swooping in to save the day. But before you start to panic, let me introduce you to the real superheroes of our story. The folks over at NASA's Planetary Defense Coordination Office. Now I know, the name doesn't quite have the same ring to it as the Avengers. But these are the people who are tasked with protecting us from asteroids and other potentially hazardous objects that may be hurtling towards Earth. They're kind of like the hall monitors of the solar system, making sure everyone and everything is where it should be. So, what does a planetary defense mission look like? Well, it's not quite as glamorous as you might think. There's no dramatic music, no slow-motion walking, and sadly, no Robert Downey Jr. Instead, it involves a lot of science, a lot of calculations, and a lot of patience. These missions start with detection and tracking. NASA and its partners around the globe keep a close eye on the sky, looking for any objects that could pose a risk to our planet. Once they've identified a potential threat, they calculate its trajectory to see if it's on a collision course with Earth. If it is, that's when things get really interesting. We don't have any laser guns or giant hammers to smash these asteroids. Instead, we have to use our brains and our technology. The goal is to deflect the asteroid, changing its path just enough so it misses Earth. This could involve launching a spacecraft to collide with the asteroid, or using the gravitational pull of a spacecraft to nudge it off course. So while our planetary defense might not be as flashy as a superhero movie, it's just as important. And it's all done by real people, not fictional characters. These folks are using their knowledge and skills to keep us safe, one asteroid at a time. So, no capes and masks, but hey, saving the world isn't a fashion show. So, how do we actually push away a giant rock flying towards us at an insane speed? Well, it is rocket science. Picture this. You're in your backyard trying to divert a soccer ball that's been kicked towards you. You could use a leaf blower to change its path, right? Well, in space we use something called a gravity tractor. This would be a spacecraft flown near the asteroid for a long period of time. The gravitational attraction between the two bodies would slowly pull the asteroid onto a different path. It's a slow process, like trying to move a mountain with a feather, but remember, in space, even a feather's push can make a difference. But what if we don't have time for the slow and steady approach? Imagine you're in a game of dodgeball and a ball is hurtling towards you. You'd want to knock it off course as quickly as possible, wouldn't you? This is where kinetic impactors come into play. These are essentially large, fast-moving objects that are crashed into the asteroid to change its course. It's like throwing a bowling ball at the dodgeball to knock it off course. Now you may be thinking, why don't we just blow it up like in the movies? Ah, the Hollywood approach. But in reality, this could be more dangerous. Imagine shattering a giant rock into 1,000,000 pieces and then having 1,000,000 smaller asteroids heading towards Earth. Not quite the solution we were hoping for, is it? And of course, there's the nuclear option. No, we're not talking about starting a war with the asteroid, but rather using a nuclear device to either vaporize a portion of the asteroid or to push it off course. It's like using a firecracker to scare off a pesky pigeon, but on a much, much larger scale. So there you have it. Diverting an asteroid isn't as simple as flicking a switch or pressing a button. It's a complex task that involves a lot of planning, precision, and yes, rocket science. So, it's like swatting a fly, just with a little more math involved. Now that we know the plan, how do we make sure it actually works? We can't exactly practice on real asteroids, can we? Well, just like a basketball player practices his three-pointer or a pianist runs through scales, scientists have their own ways of rehearsing for a potential asteroid threat. They use what's called simulation exercises. Now these aren't your average video game simulations where you sit on a comfy couch with a controller. These are complex, intricate models that help us predict the behavior and trajectory of an asteroid. Think of it as a cosmic game of billiards, with Earth as the 8-ball we're desperately trying to avoid. But wait, there's more. Scientists have also launched missions like DART, Double Asteroid Redirection Test. It's a bit like a cosmic game of dodgeball. The aim? To hit an asteroid and change its course. Now this isn't a game of chicken where we wait until the last minute to swerve. No, this is a carefully planned precision mission. It's a bit like trying to hit a home run on a pitch from 100 million miles away. No pressure, right? And the stakes? Well, let's just say they're higher than any basketball hoop or skyscraper. We're playing for our planet here, folks. So remember, the next time you see a shooting star, make a wish that it stays a safe distance away. So that's our plan to save the world from asteroids. Not as flashy as a superhero movie, but definitely more practical. Can you imagine? We've just spent the better part of 7 minutes discussing how we'd tackle a rogue space rock. We've delved into the nuts and bolts of planetary defense, realized it's actually rocket science, and dabbled in some hypothetical practice sessions. All without breaking a sweat or donning a spandex suit. We've learnt that we don't need capes or magic hammers, but a solid defense strategy, some good old science, and a dash of preparation. It's a fascinating journey, isn't it? From the big question to the nitty-gritty details, we've covered it all. So, if you fancy more of these cosmic crash courses, why not stick around? There's always more to explore, more questions to answer, and more space adventures to embark on. And remember, if you see an asteroid, don't panic. We've got a plan. Subscribe and stay tuned for more exciting space adventures.